So in this video, we're going to look at the actual example on how to prove that the two vectors are perpendicular. So here we've been given vector A, which is I plus 2j plus 3k, and vector B is 3i minus j plus 0. And in most cases, they just indicate, they do not indicate when something is having a 0 there. So what we're going to do is we are going to use the dot product. So we have A dot B, that must give us the magnitude of A times the magnitude of B, then cos theta. So this is what we are going to use. But we know that we were given to say A dot B, this one, A dot B. So A dot B, A dot B. This one is AX BX plus AY BY plus AZ BZ. Then this one, the magnitude of this one, the magnitude of A, the magnitude of A is given by square root of AX squared plus AY squared plus AZ squared. Then the magnitude of B, we have square root of bx squared plus by squared plus bz squared. So now, if we come to this, that is A dot B, so dotting this and this one, we are going to have, so this one, that is I plus 2j plus 3k dot, that is the B, so 2I minus j plus 0k. So this one must give us, so this one, the magnitude of A, which is the magnitude of A and the magnitude of B, then cos theta. So without even wasting much time, we can in fact even divide by magnitude of A and magnitude of B. Then even here, the magnitude of A. So, but we know that this magnitude of A is given by this one. It is given by, okay, the square root of this one, which is, okay, in the meantime, we'll just write like this. So magnitude of A, the magnitude of B also here. So that this and this will cancel, and what we're going to have is cos theta is equal to, here we can even dot them. We know that A dot B is equal to AX BX plus AY BY plus AZ BZ. So here we're going to dot this one and this one, and I times I, it is 1. I times j is 0. I times k is also 0. So under dot product, if we are dotting this to a different letter, different from this, then the answer is 0. This times this, it is 1. This times this same one, j dot j, or yes, j dot j, that is the proper language for dot product, it is 1. K dot k is also 1. So here what we're going to do is, so this times this, we have 2, then I squared. So I squared is 1. And 1 times 2 is simply 2. So we have 2 here. Then this dot this. So 2j dot j, we're going to have negative 2. Then j squared will give us a 1. So it will be 1. It will be negative 2. Then 3 times 0, this is 0. And what we're going to have is over. So the magnitude of A, we have magnitude of A is this one. So we have 1 squared, which is just I squared. So we have 1 squared plus 2 squared plus 3 squared. Then we also have for B, which is square root of 2 squared, which is this one, then plus negative 1 squared plus 0 squared. So here what we're going to have is on top 2 minus 2 plus 0, we're going to have a 0 over. So this one squared is 1, then 2 squared is 4 plus 3 squared is 9. So 9 plus 4, we have 13 plus 1, we have 14. So square root of, so this is 9 plus 4, 13 plus 1, 14. So 14, and this one, 2 squared is 4 plus 1 squared, which is 1. So we have square root of 5. And this one, we are going to have cos theta will give us 0 over square root of 14 square root of 5. So 0 divided by any number, the answer still remains 0. So we have cos theta is equal to 0. Now if we want to find the theta, we do this and it will be cos inverse of 0. And this one, cos inverse of 0, if we punch this on a calculator, we are going to find that the angle will be 90 degrees. So theta will be 90 degrees. And if the theta is 90 degrees, which is the angle between the two angles is 90 degrees, then it means the two angles are perpendicular. Thank you so much for watching the video.